Nee. Good morning, Martina here.
Morning, Martina.
How are you?
Well, thank you.
That's good.
Good morning, everybody. We're just waiting for one or two more guests to arrive. But in the meantime, I will request that Mzi takes over as host. Enjoy the webinar today. Thank you very much. Please ensure your microphone is muted.
Good morning, everyone. Thank you so much, Helen, for organizing and all the participants that are attending. My name is Mayedwa. I'm the Volunteer Director of Drowning Prevention for Lifesaving South Africa. And I would like to welcome all our guests who are attending today. And thank you so much for making the time. And for those who are attending for the very first time, this is our third session, or part 3 of our session of flood and water swift rescue drowning. The first one, we were focusing on the principles of emergency. And then the second part was focusing on the 4 phases of flooding. And today we are focusing on rescues as well as the personal protection equipment, which is also the flood and hydrology. This also includes a South African Red Cross presentation from Irene, who will be talking about the Red Cross Society disaster interventions, some of the interventions that they have had or they are experiencing within South Africa. At this point in time, Irene is currently responding on Cape disaster that is actually taking place, and she will join us later. We are hoping that she was going to be the first one to actually present. But with that being said, I will just hand over to Dr. Shayne as well as Adrian to actually take us through on their presentation. And thank you for everyone for attending. Oh, Dr. Shayne and Adrian, over to you. Thank you.
Thanks very much, Mizzy. It's really good to be back again. 3 weeks, the 3 weeks break between each session seems to sneak up on us in a very quick succession. So tonight, Amy's not joining us. Amy Pearden, for those that may have seen the initial slide, Amy's working with us as we have been gaining feedback from people. And when we run the last session, we're also going to ask participants if they don't mind to also provide some feedback. Having the opportunity to deliver the program in collaboration with Lifesaving South Africa has enabled us to explore some different ideas on how we can share this information. And obviously there's actually been some other interests from other jurisdictions. So we're keen to be able to build on this and to enable it, particularly under the current corona situation. So your participation and interaction has really been valuable to all of us. So, and by all means, if there's anything tonight that you need to know, Helen, I know, is standing by to interpret and pass on any questions as we go along. So as per the introduction, tonight we're going to explore a little bit more of the procedures. And for those that have come in for the first time, I guess one of the underpinning approaches that we've tried to capture with what we're doing is we know that there's a lot of people from various life-saving organisations, drowning prevention and disaster response. And what we're trying to highlight is that, yes, we do have a lot of experience, lots of information and lots of capability, but we need to actually know a little bit more. And we also need to know how to look after ourselves. So no different than that when we put ourselves into the ocean. The aquatic environment generated through floods is certainly not the same, and we need to be able to recognise those dangers and to look after ourselves. So there's a personal aspect to what we're doing, but obviously by building our own personal knowledge, it builds our capacity into the future to deal and respond. So I think I now need to share my screen. Is it? That's right, isn't it? I'm to do it from this end, Mizzy?
You can, otherwise I can share for you.
Oh, okay. No, that's fine, Helen. Go right ahead. Let's make a start. Thank you. So the first part of the session, I'm going to specifically talk about the flood hydrology and recognising some of the differences that we probably are not aware of if we come from an ocean or a freshwater environment. And in this particular, so I'll lead that, and then Adrian will take on the introduction to some of the rescue techniques associated with flood rescues, and also the very important issue of the personal protective equipment, because what we use in life-saving is not always going to be the best fit. And as you see from our first slide, the lady there looks quite happy because I think these two rescuers were on her annual calendar. So she's feeling quite happy because she got the two calendar guys that have rescued her, maybe. Okay, next one. Thanks, Helen. So just a general overview in terms of the actual process of how the water actually starts to happen, as we know, on land surfaces. So this is a little bit different from the other sessions we've run. Starting on the left, we see the cloud building up and the condensation. That is actually drawing up moisture from the planet or the Earth. That then starts to build up into precipitation, sorry. And then, of course, we've got rain, and then we've got our surface runoff. That surface runoff, some of it, depending on your continent, our country, of course, in Australia, the driest continent on Earth, or one of them, we certainly need to see a lot of rain before we see that build up of groundwater flow. There's a lot of water that's actually absorbed initially, but then it starts to flow. So it cuts through the land, it actually moves in straight lines, so it's a vector as it moves from one point to the other. And next slide, please, Helen. So the flow dynamics, somewhere in all of the precipitation, the water will actually go into the natural waterways. In most cases, it's the rivers and the creeks that'll start flowing. And if we take a cross section of water that's flowing through a natural causeway, and those dynamics, you can see there from that graphic, the central part of that water flow is actually going to be the fastest. Similarly, as we go deeper, you can see that the water actually slows. So, and this gives us, for those that are involved in rescue, obviously this is not new information, because if somebody submerges, sometimes if they're in the middle of the water, you think they've gone a lot further than they will have drifted. And then of course, once we get right to the very bottom and to the sides of the actual river, the water flow is quite slow by comparison. Next slide. Oh, we got the, sorry. Yeah, this just shows the flows. Okay, we'll come back next. So just showing the actual flow itself. So in the center, and as it works its way to the bank, we have quite a laminar flow. It's moving fairly well in that vector direction, and quite easily to determine. As we get closer, there's going to be more debris and the interference of the bank. So the flow starts to become helical. So what happens is that you'll see different things as if you throw something into the water, you'll see a different pattern as it emerges. Thanks, Helen. And one more. There it is. So the other activity, particularly with, we've got the same cross section there, but now we've introduced the idea of having the bends in the river. On the right-hand side, we can see that the inside bend, and then on the outside bend, we can see there's some tree roots. And as you can see, again, the main current, in this case, because the inside bend is actually slowing, that breadth of water is actually a lot thicker there because of the impact of the bend. So we see that actually stretching or extending out towards the center of the actual river, whereas on the outside, those restrictions are not so. It actually picks up speed. So obviously, when we see anyone in difficulty, that obviously we prefer them to be coming towards the inner part of the riverbank rather than the outer, because that's where it's going to be a lot faster and a lot stronger. Thanks, Helen. And so now we go a little bit, get the drone's eye view, so to speak, because the other thing we've got happening, as you can see on the inside of the river bend there's a little bit of activity on that image, which is highlighting that's where it's being impacted by the inside bend. On this particular one, we have a rock that's towards the outer side of that river bend, and you can see the vector and what the current does when it hits that rock. So when it hits the rock, again, just on the extreme parts of it, that's where the water again will still be flowing quite quickly. But as it comes into the rock there's a lot more turbulence, a lot more interference. And of course, immediately on downstream of that rock, there's actually a quieter and a slower moving section of the water. Thanks, Helen. So taking that image from graphics to actually seeing what it looks like in reality, as you can see here, we've got a natural waterway. We can see the faster water flowing through that yellow line there. On the left-hand side, we've got a projection of land and some rock formation. And again, you can see the vectoral changes and how that water is moved back towards the center. And then over on the outside, you can actually see that water bubbling. So it's a very good image to verify what we're looking at. So a bit like for lifesavers being able to recognize rip currents, it's important for any of us, if we're involved in a flood situation, to be able to recognize what that water's doing and where the most dangerous aspects of it are. And next slide. One of the things that some people are quite surprised about, particularly with flood water, because we know sometimes that the flood water may not necessarily be all that deep. is actually what the force of that water actually contains. So in our country, there's been a lot of effort put into messaging around don't drive through floodwaters. And the simple reason for that is because the force of the water and the basic law that's listed on this actual presentation slide shows that as the water increases in velocity, we actually tend to see a increase in force by quadruple, so 4 times. So and the next slide gives us a little bit more of a graphic explanation on it. So in this particular case, Adrian likes to use miles per hour, but I keep encouraging him to come into the 21st century, and we've got some kilometric speeds here. So for a speed of 5 kilometers per hour, the weight on the leg is 7.6 kilogram or 75 Newton. Obviously the body, there's a bigger mass, so we can see that over on the right-hand side, that increases. So we double the speed from 5 kilometers to 10. That weight on the legs is now 30 kilograms, which is 300 Newtons. So simply by doubling that, we've gone from 75 Newtons up to 300. And of course, as we go further, there's not too many of us that if that water is flowing at 15 kilometers an hour and it's only up to your knee, you'll have a great deal of difficulty staying on your feet. So that's really what this little slide's trying to highlight and really give everyone a very clear understanding of what we're doing here. So the major loading, and on the bottom of the screen there, the major loading can apply in just shallow water, and some of the situations that I've been party to, and I'm sure Adrian can attest to, is you do not need a lot of depth of water that's going to move a large body such as a motor vehicle, let alone a human. Okay, thanks, Helen. Next. So I added this. This is some work that was done by Mike Tipton, and Adrian was part of the research team at Portsmouth University. And I thought it was quite valuable, again, just for us in the warmer climates. Obviously, we've got the thermal issues as the temperature increases. But so for us, a temperature of 15 degrees and with a flow rate of 3.2 kilometers an hour and an air temperature of 20 degrees Celsius, we have a load on our cells. So this is based on being in water up to the knee. There's 10 kilograms with 15 degree water, air temperature 20 degrees. You sort of think, well, that's, you know, probably the water temperature in particularly in the northern parts of Australia are quite a little bit higher than that, but the southern parts, 15 degrees, probably quite common. And that's not a very high flow rate there. It's 3.2 kilometers. But the actual increase on the body temperature is quite substantial. So we underestimate, even though we're talking about people that are reasonably fit and able, when we see that we're going to put ourselves in these predicaments. And by the way, on the top of the slide there, the personal protective equipment, if the people are wearing their dry suits, their PFDs, helmets, we're talking about a load already on the person of 9 kilograms. So we've got that exasperated by the actual flow of the water. The same consideration in terms of that heat is also that as we being exposed to heat, we're also going to be prone to heat exhaustion. So imagine if you're in a full dry suit with a helmet, with a PFD on, trying to move through a fairly strong flow of water, it's going to be quite energy sapping. And we need to also consider this as first responders potentially in a flood situation. On the other side of the coin, as part of this experiment, they changed the water temperature to 7 degrees and just were in the water for an hour. And I think Adrian was one of the test recipients. So it was basically being in the water for an hour, 7 degrees Celsius. The air temperature was 4 degrees Celsius with no load on them. But one of the interesting things that they kept testing, it was the actual muscle function, and it was reduced substantially to the point that one of the participants had to be removed from the water after 10 minutes. So anyone that's got any sort of physical ailment can be found wanting when they have to experience this sort of exposure. So the cold water exposure incapacitates quite substantially. So for a 3% reduction in the power of the output of the muscle per degree Celsius. So for every Celsius degree that falls, your power and your capacity to manage your own physicals, particularly the finer motor skills of tying a rope, for example, becomes quite a challenge. Okay, thanks, Helen. We'll move on back into the hydrology aspects. Next slide. So we've got a fair idea of the personal impact of both the flow of water and also the thermal temperature of the water. And just by this slide here, you see we're seeing highlighting some of the damage that can be done. And obviously in these particular slides, as you can see there, this is after the water has receded. Again, highlighting the fact that with floods, if the water's flowing, even if the water doesn't appear to be flowing all that rapidly, we don't know what damage has been done underneath. So here's a classic example. If the water hadn't been that deep, either tried to drive across this road or even walk across it without some sort of a pole to check what's underneath the water, they could have got themselves in quite a deal of difficulty. And the mapping there, which isn't as probably clear as it could be, but it highlights again that expansion issue of floods. And on our very first presentation, Francisco also shared some of the potential mapping that has been done in South Africa. And obviously having this sort of data and having this sort of intelligence is crucial. And we also talked on the other presentation again about that communication. So this particular slide highlight that the force of water and the damage of the water is something that we need to be able to communicate and verify as we get involved in these situations. Thanks, Helen. So in this particular example, we're upstream and highlighting again, the hydrology of a particular blockage. So that blockage could be something that's natural, such as a rock, or it could be a motor vehicle that's come into a particular flood area. And as you can see, we're looking at how that water then is going to affect it. Next slide. And in this particular scenario, this is actually a training facility that's used for flood technicians. And as you can see there's a number of scenarios being man-made with rock-like formations, drop-downs as per a weir. And you can see a very good graphic there, particularly with the water flowing through in the laminar or the straight line coming through that weir to the circular currents over to the side there. And obviously, when you come down through those particular test areas, ideally you want to get to the side rather than stay in the middle. Thank you. Next slide. Then we got the situation where we have the impact of, say, two strains or vehicles or blockages. And as you can see there, they're going to change the course of the water. And that particular section where the arrow is showing is going to highlight, is going to be obviously moving at great speed. Ideally, anyone that's going to be in that water is in a serious amount of trouble, but the general principle is obviously they need to survive it and stay away from those rocks if they can. Thanks, Helen. And again, the graphic, we did have some very interesting slides from some major floods previously, but I think having the diagram just helps to reinforce the sorts of things. So anything that's in a natural waterway where there's flowing water, we have what is known as strainers. So those strainers can be in the form of overhanging branches. We can have fallen trees that collapse because the water has come around in those river bends, and as we saw where the tree roots are down onto the riverbank, very quickly they can be toppled over. We also have in rural properties, we have fencing, and that presents a massive threat to anyone that enters the water simply because of that, in a lot of cases, unseen situations. Rocks, obviously, a little bit easier to spot when they're higher, but we don't know what's underneath. And then there's just going to be general debris that's been washed down through the floodwaters. So the key message there at the bottom, which is probably, again, stating the obvious, is that water will pass through all of those things that we've just listed there, but people won't. So if we get into that sort of environment, we are at high risk, high danger, let alone as a rescuer, but also as a potential person, and how we're going to survive that. So ideally, we need to be aware of those situations and we need to avoid them, because anyone that's tried to extract someone with water pressure on them that's being held up by a strainer of some sort can tell you that it's not an easily achieved rescue. Thanks, Helen. So now we talk about some of the waves that we'll see in a strong flowing water. So this could be, when we go back to our 4 phases, this could be the rapid phase. So we've got a lot of water flowing and the water's going to perform in different ways. So what's going to cause those waves to stand? You've probably got a few clues already. Exactly. First thing is going to be what's in that river. So where there's large rocks and movable objects, when we see those waves or see that water coming up vertically and frothing up, we need to be very aware that there's something that's doing that behind that water. And obviously we need to avoid that. If it gets, the water gets deeper, there'll still be an element of the water rising up. It's possibly not quite as violent, but as you can see by the graphic, the actual reactions on the downside, because the water's come up over the actual blockage and then comes racing down on the bottom side and then throws up water on the bottom side of it. So again, it's still a signal to be very aware of what's in that water. And this graphic just gives you that little bit of a imagery in terms of what's actually happening with that water. So the water comes down, hits the blockage. We have the reaction wave, which could be broken or may not, depending on how significant the blockage is. There's going to be water coming around it. And then as it comes up and then drops down over the face, all of that combines and creates that backwash or that kickback of that water, and it boils up onto the river surface and then eventually spits it out down the other side. So there's some points to think about. If a person actually goes over that reaction wave and down into that other side, they're in fairly significant danger. Thanks, Helen. One of the ones we don't see too many weirs because we don't have that many flowing rivers, but possibly in Europe and some parts of Africa, there certainly is flowing water, and there are weirs that are built to manage and help control the flow of water. They actually present a very significant danger. Most of us probably know where possible, a lot of signage is usually done and provided around weirs. For some reason, it doesn't seem to necessarily prevent anyone testing their skills and ability. As you can see there, we can see the water actually dropping down a bit like we saw on the previous slide. As it drops down off the weir, we've got that back face, and it comes down, and you can see the water is bubbling up there. And we've got another graphic just to highlight that, I think, on the next one. So the big issue, of course, is any person that goes over a weir into that area is going to have a great deal of difficulty getting out of that area. And some of those skills and ideas of rescue that we probably know from particularly surf environments, we know that eventually the wave breaks and the wave moves forward. But as you can see by that this graphic and the previous image, the water is actually continuous. It doesn't dissipate. It just keeps coming over the wall. So it's an extremely dangerous situation. So in terms of how best to respond and deal with some of this, we need to start to talk about some of the rescues. So I think I can have a little bit of a break, and I think, yes, Helen, it's I'll mute myself and let Adrian come in from this point. Thank you.
Thanks, Shayne, and thanks, Helen. Good stuff. Lots of information now. We know it's a lot of information being sent to you, and normally it just takes a lot of work and program with you, and I'm sure you have a lot of questions. We'll talk about training in our final part 4 in a couple of weeks time, but we just want to get this information out so you can discuss and hopefully see where we're going. But understanding hydrology and understanding the flood concepts in an urban environment starts to make us understand how we're going to risk assess. So great work by Shayne. Okay, Helen, can we move on to the next slide for me? Lovely. So we're just going to very quickly talk about the technical equipment. As you see, and you're seeing in our photos, there's a lot of dry suits here and not wetsuits. The reason for this is in 2 parts. A, we're trying to deal with the cold water shock. So having something over our arms and legs and body reduces cold water. And it may not seem like in your country or in Australia that we get cold water, but in fact, flood disaster water is dropped from the sky at a very, very high level. So the temperature of the water has a huge effect on our body. And so protecting us against the cold water response or the cold water shock is paramount. And in doing so, a dry suit with an undersuit helps alleviate that. Now, the other part of the dry suit is the fact that we talked in our 4 phases in part 1, is that it's a biohazard, it's a contamination hazard, because all that water that's dropped down from the rainfall is taking waste and agricultural waste and industrial waste, battery acid, car pollution, dead animals. All those things start to enter that water course. And so with a wetsuit's designed to trap water in the material, and therefore our body heats it up and keeps us warm. And that's how a wetsuit works. And the problem with that, when you're dealing with contaminated water, that contaminated water is next to your skin. And just as a point from that to share with you, that during the Katrina disaster in America, in New Orleans, you know, there was a huge initiative that brought the US Coast Guard in, and wenchmen were dropped in with their wetsuits to rescue hundreds of thousands of people. But in 4 days, they started to feel that they were getting ill and started to actually come off the run and be hospitalized. And in fact, in 4 days, the Coast Guard winchmen were down by nearly 70%. And this is because the contamination of the water had got into their wetsuit and started to affect their skin, and then they started to become ill. So it's important to understand that, yes, a wetsuit is better than nothing, but a dry suit's going to keep you a lot better protected. And if with flooding, we're in it for a long haul, and you need to kind of eat, sleep, and repeat, as they say. If we can keep our responders in the fight for longer and manage them, i.e. like understanding what happens to them when they move around, which Shayne talked about. So effectively every hour, they need to be drinking about 500 milliliters of water. They need to be eating, you know, a couple of 100 calories every hour, because equivalently, they're running a 10-kilometer race for every hour and a half they're moving. Now, a life jacket is fine as long as they're wearing crutch straps, but it doesn't actually allow you to self-rescue very well. As you know, with some of you with a marine background, you fall in, it inflates, and it rotates to keep your head up. That's great if you are in a survival mode or you are unconscious, and relatively, if the life jacket is correct and fitted properly, then that should keep your head relatively above the water. Now, the difference between that and a personal flotation device, or PFD, as you see in the picture here, is you can see that, yes, they could land face down, become unconscious, and not be able to right themselves, but it does a couple of things. First thing, we need them to move around in boats and in water successfully and swim across and wade across. And the other thing it does, it actually gives a bit of thermal protection. And the final part, it actually gives a bit of padding. So when you are in flood disaster, because as Shayne said at the start, there's debris in the water and some of it's hidden. If a log or a bit of wood comes down and hits you in the torso, you've got some padding to protect. The helmets you see are white water helmets, and they give some protection. They're effectively two types of water helmets you should think about. One helmet is really to do with the white water as we see, which is I don't know what the safety standard is in Europe, in South Africa, but we call that EN 1385, and it's designed to work for kayakers and paddlers. But it's not designed for powered craft now. Some of the things that we've learned now from a couple of accidents, that the standard of PAS or PAS 028 is a powerboat helmet, and that's designed to protect you at speeds of over 16 kilometers an hour. So you'll see our people now have a mixture of the white water helmet in low speed maneuvers or low energy water or walking and wading. But if we're in high powered craft, you'll see that helmet being used at a more protected level. And the type of helmet you can see, we can just about see, is the gentleman we're using the first aid bag at the back of the picture. Okay, moving on, Helen. Thank you. So throw lines, it's our first line of defense, and one of the first things that we are going to be using in terms of rescuing each other, and actually for those candidates that are hanging onto the lamppost or whatever that certainly need help. It is an art form, and it is different to what you see in swimming pool competition lifesaving and in open area space. And the first part is to understand the throw bag needs to be well maintained, and you need to make sure that when you get a throw bag, you put it all out, and to make sure that knot in the bag is completely tied properly. Generally, you might see a single sheet bend. I'd probably go for at least a bowline, if not something more rust like a round turn 2.5 inches, or some sort of a kind of double knot in there that you would expect to see, and it's checked regularly. When you are looking to throw in a rescue and you are looking to deploy your throw bag, as the picture shows, you should take a few leaps out of the bag and practice and aim for the amount of distance the throw bag needs to deploy for. So if you have a 15-meter bag and you're rescuing somebody 5 meters away, they don't need 15 meters of line because it become too slack. So you probably want to pull out, half of that line in that bag in order to make sure that as you hit them or line them up and land that bag on them, that as you start to pull in that line becomes tight very quickly, because as the victim starts to grab hold of that line, they're expecting that line to become tight. If it's not, then that victim will go into self-survival mode and let go and try and survive. So you need to be practicing that, you use the right distance and the amount of line needed. Never ever wrap a line around your hand or your body. It is really, really important. Quite often we're kind of taught that in a poolside or stuff like that, but you're dealing with the forces of water that Shayne spoke about at the start. Now, if that force of water is 10 miles an hour, or so 10 kilometers an hour or 15 kilometers an hour, we've got loading of 90 kilograms coming on you, and that's going to take your hand pretty bad. Even it's going to deglove your hand, or it's going to pull tendons, or even pull your shoulder out. So the worst thing is that the whole thing gets wrapped around you and it pulls you into the water itself. These people are being dragged by a huge amount of force. So being able to let go and being free and being upstream of a line is very, very important. Keeping that line clean is good as well. So we don't tie knots, we don't have loops as such. Now you've seen the picture as a bottom loop, and I would criticize that picture, saying I'd want that line at the bottom of that throw bag to be tighter and that loop to be as minimum as possible. And that's just for other technical rescue elements that we don't have time to talk about today. But anytime there's a loose bit of rope, it's a bit like having a viper in the water that certainly has a chance of biting you, and that's what ropes are. And so as much as they do good and they can rescue, they can also wrap you and capture you out and do some significant damage. So that's why we train a lot with our ropes. And all our ropes are floating lines as well. They're not sinking lines. That's killed a number of firefighters in the Western world. And so one was a firefighter who was in charge. Nobody could swim. 2 kids had gone missing in a lake. And he decided to tie a rope around himself, went to get into the water to swim, was overcome by the cold water. And as he started to have his ability to swim compromised because of cold water shock, the chaps in the fire truck who were already on the land pulled him to his safety, but not realizing that rope had sunk and wrapped itself around a root bed, and they pulled him to his death. So all ropes need to be floating lines and able to float and have a bit of strength as well. So it's important that they do, because once they've been thrown and deployed in a real action, there's huge amount of strain on that line. We never put a line 90 degrees to the current vector. So that's, in your eyes, a straight rope going straight across from one bank to the other. The reason for this is that if a victim does come onto it, they'll create a V, and they'll be permanently stuck there by the pressure of the water until something happens. And the only way to release that is one end of that line needs to be released, so it pendulums back in, or create a diagonal that they can slide down the line from one end to the other, but it should never be 90 degrees to the current vector. As mentioned, you need to be prepared for the line to become loaded, and it's a bit like thinking in your head of if any of you guys have been farmers and cows, that you've tied a harness to a cow, you've cattle pronged it with your ironing on your mark, and it goes all wild and it starts to run down the field, and you still hang on to that line. So you need to be prepared for that line to become massively loaded. And in 2 parts, there are 2 ways to deal with that. One is a static situation where you would sit down after you've thrown and somebody holds your shoulders or your life jacket, your PFD, because you're going to get dragged along, and you can use that kind of static anchor point to bring the person in. Or you can be a roaming one, where you roam along down the stream with them or down the flow, and as you pull the rope in towards you, you're walking at the same speed as this person going down. But these are all tactics that, on the day, you have to be comfortable with. And we always stand upstream from the line. We never have the line above us with the flow, because in case it wraps itself around us. Moving on, thanks, Helen. So this is just a very quick example of a static throw, having the target zone in your place and throwing at or just upstream of the subject, and with the current flow coming down from the top of the picture to the bottom. The reason for this is, as you saw in Shayne's picture, the top surface of the water actually moves faster than below. So that rope will catch them up. If it's slightly too in front of them, but by, where their knees are, they may find it difficult to catch up as that surface water starts to move faster away from where they are sitting deeper in that flow of water, or that laminar flow of water. Next slide, Helen. So what happens if we do fall in? And yeah, we will, and that will happen. And even if you are in this situation, and something that you can teach to other people in disaster zones is, first of all, if we've got some PPE like a life jacket, which you can see in the picture, that's great. If not, if you're teaching school kids, with disaster, heavy rainfall or tsunamis, have something that you can hold on to that floats across your chest, and grab that and put it close to your chest. Stay calm and relax, and let that cold water shock go past you. That will last a couple of moments, in terms of 1 or 2 minutes, until your breathing starts to get itself organized. Lie back and keep your bum up and your face downstream. This stops you hitting any objects, as you can see in the picture, that could be below the surface. And having your feet downstream means you can kick off any objects that you can see, and allow yourself to be maneuvered out the way of any of those objects. Look for where the current slows down, and then when you see it starting to slow, you can attempt to swim back using one-arm sculling or kicking, or changing your body. Those of you in a marine background, we talk about the ferry glide, where we move the boat, moving from left to right, but not moving forwards or backwards. We can do exactly the same thing by using our body. So if we're going down the river and we're facing downstream, we turn our torso to the side of the bank that we wish to go, and the water from that vector will push us across to that side. And this is the example here of the ferry angle. Now remember that we looked at the white arrows here as the vector, and not necessarily the lines of the water bank or the riverbank or whatever that environment is. So you're looking for the straight laminar flow to ensure yourself where you can get your angles to get yourself out. Thanks, Helen. So just moving on is how are we going to plan to be safe and how we're going to operate and how we're going to communicate that. Thanks, Helen. So we need to understand our risk management strategy. So any of my flood teams that I've operated, we don't just start rescuing and thinking we can do stuff. We actually write a risk assessment out because every area is different. Every land is different. The topography or morphology is different. Urban environments create their own problems. And so we need to have a really understand of what we're going with. And very much as Shayne said, what is going on under the water in an urban environment? Has a drain cover been moved? Has cars around there? Is there a post box there? And actually using things like Google Earth allows me to see what those areas look like in a normal day-to-day environment. And then I can use that photograph and have a look to see if it's anything's different from what I'm seeing in reality. And, you know, things that may be submerged but permanent, such as a park bench, I can identify that and use a real-time plan with my operators. Work in pairs is crucially important because you could be dragged away, you could fall in, and so having somebody, a buddy person with you, can always keep checking that you're operating safely. When we're operating at a rescue site, we need to have some upstream spotters to make sure no debris is going to land into the rescue site. The further, the better, and communication is a strategy that we must think of, whether it's whistles or radios. Just an example of that if we have an object or the water moving down at 16 kilometers an hour, and you know, and we've got, say, a sofa bed coming down the high street, you know, in 400 meters, that's going to hit the rescue site in about 90 seconds. So the further the better, to give time for the rescuers to sort out the situation and also to keep their safety. The last thing they want to do is jump into the water and go smack, and they've been hit by, you know, a park bench or a car or whatever, and that means you not only you've got one victim that's been dead, but your two rescuers are now dead. Your downstream backup should also be matching the rescue situation or better. So as you see in the picture on the right, we've got a backup team throwing a bag onto the victim, and that's great because upstream of that would have been another throw bag that's probably been missed. So if we are choosing at the rescue site, say a throw bag, then the backup team should be equal or better. So the backup should either have a throw bag, or it can have a swim rescuer, or it can have a boat, something like that. But it can't be less than the rescue situation that you have there. And also the safety cover. Who's got eyes on the overall picture is really important. Thanks, Alan. So where we are just now, we're only talking about this situation now, is the rescue options. Talk, reach, throw is our main subjects of really our low-hanging fruit, where we don't actually have to get wet. And actually, if we do our job well, that's where we want to be. They are the safest options. When we start to get into water, whether we're wading or using a powerboat craft or swimming or using a helicopter helo, that's where the risk ramps up massively, and our training and understanding and our ability to use our judgment and our experience and the ability to use our flood rescue techniques is really important. The problem is here, as you can see, the words victim school, is when we train, we always make each other easy. You do that in your lifeguarding, you do that in your military background or civil protection background, where we just help each other out a little bit. You know, we get on, you know, if we're a victim, we just help move into a recovery position for them, or climb onto the rescue board a bit better, or help with them getting them out. You know, we've got to get away from victim school. You know, victims don't help you at all. Their only issue is to survive and get air in and out, and to get from a bad place to a good place. You know, and going back to the throw bag, you might be the best throw person in the world, but if this person's thinking that I'm very cold, hypothermic, I'm clinging onto a lamppost, street lamppost, the water's moving at 8 kilometers an hour, and you're asking me to let go of one hand and grab an 11mm diameter rope, think again. You have to work out what that problem is. Moving on. So our rescue planning, as I want to remind you, is the mnemonic last. First thing we need to locate them. Where are they? Where are we going? What is that area doing? Access. How do we get to them? And how do we egress out? Because in flood disaster, our exits and access areas can change rapidly. And quite often when we've done training, quite often we get dogmatic in our approach, where we've come in that way, so we must go out that way. And really, we could have looked on the map and realized there was a quicker route out. So locate, access, and egress are very critical indeed. Stabilization is important. Stabilizing the victim from not getting any worse. And that could be using a rope, dropping down with a rescue tube and holding them to hold on to something while better rescue techniques are used. It could be that we stabilize the area where we stop people going in, or we stabilize a situation where the civil protection teams are getting a little bit loose, they're starting to panic, and we stop the situation from escalating or getting worse. And the final part is T, is transport. You know, how do we get from a bad place to a good place? How do we move from A to B? Because it's not going to be any easier in flood world. In fact, you know, in some of the disaster zones I've been in, you know, what is a 5 kilometer in a car that can take minutes, can take hours to get to. So we need to think about all that logistics in our rescue planning. Thanks, Helen. So just moving on into our flood safety and talking about those areas now. Just going to remind you, that's it, go on, Helen, thank you. Is just to remind you in our flood safety that we've kind of got 4 areas to think about. We've got the fluvial, which is the river courses, which you see in the picture here. Pluvial, which is the rainfall, and the urban surface water that's going to affect your areas. We've also got groundwater. Don't miss, quite often people misjudge this, that when water comes in, it comes up into our groundwater areas, very much as Shayne talked about, and can sit there. And if you have a consistent rainfall, groundwater starts to bleed out into our soil and into our roads and start to have an effect like that. And then some of you is coastal inundation. And that is going to be a huge threat, you know, in the next 30 years with climate change. Already we're predicting, you know, 2 centimeters over the next few years, and this is only going to get worse, which means that when we have lots of swell and lots of water coming through, with the ice caps starting to melt, that's significantly going to have an impact on coastal areas. Thanks, Helen. So our sources of this, oh, sorry, go back one for me, Helen. Thank you. Pluvial results from rainfall generated over land and the flow before the runoff enters the watercourse. So this is the kind of UK questions that I know, but some grounds can accept more rainfall than others. And so I asked you to tell, you know, go and find out, what does high intensity? High intensity for me is 40 millimeters in a day that I start to be aware of, because that equates to us in the UK of around about nearly 3 weeks worth of rainfall. When I start to have a look at major rainfall, I'm looking at 80 to 100 mil plus. And in some cases, you know, we start to see 200 and 300 has huge consequences to what we need to do and plan. So being aware of how much rainfall can our land take, or our cities can take, where we start to lose is really important, and have that in the back of your mind as your pre-plan. Low intensity could be snowmelt, and I know in South Africa you have a little bit of snow, but not always. But snowmelt does have a kind of an effect in some areas. And your sewage systems will be overcome. So what happens when they start to go? Because once we lose that, and the sewagery and the cleaning, we are really in the mire with everything that's going on. And as you can see with the picture, you know, you do not want to be walking in wetsuits. You want to be walking, as you, men and women are here, with their dry suits on to get washed down easy. Difficult to predict, I know, and sometimes short time warnings, lead time warnings. But if we can get that better and move resources early instead of dragging or pushing them in, is a much better way. Because if you start off behind the curve, You will never, ever, I've done this for 20 years. I've been to 5 major disasters worldwide, and I've done major disasters in the UK. And I keep saying that if you're not in front of the curve, you don't win the war, and people start to get injured. So, you know, moving early is much better to say, thank you very much, go home, it didn't happen, than trying to push them all in when it's too late and you've lost your roads, you've lost your access, because it takes so much time to set up teams and get them moving. Thank you. So this is a nice picture of the coastal inundation. So the top picture here is in New Orleans. You can see how much that affected. And the bottom picture here, you won't believe it, this is the UK. That is a harbour wall at 20 metres high in Portreath. So that's a 20-metre wall, and probably reckon that wave height is about 40+ metres coming through. It was huge, and that was a storm that came in the winter of 2014-15. Flooding from high tides impact, or king tides, on coastal areas, and they will only get worse. The warning is now, we're saying that we can't win the defence against the ocean. It's coming in due to climate change, and within the next 70 years, it's going to have a significant impact unless we don't take some drastic changes in looking after the planet. The greatest inundation areas, or harbours, or low-land areas, like places like Durban, are going to get worse. And so what do those plans look like? And can cause mass destruction to the topography. You know, once water's got in, you know, if you've got too much of a strong defence, the water can't get out. If your drainage systems aren't good, it takes a while to get out. So all those things. So tidal predictions on storms can be a really good way of providing early warning systems, and also, again, getting your resources and your responders ready to ramp up, to start knocking on doors to say, have you moved your stuff upstairs? You know, where are the vulnerable people assessment going on? Where do they live? You know, how many are there? Do we need to move them out? What does that all look like in terms of our humanitarian support? Thank you. So coming to the last few points is, you know, because we are going to talk about the training standards in part 4, but I'm going to put this to you because we've done this in 3 parts in the speed thing. To be good at this, you need training, and you need really, really good training, and you need to practice this regularly. An example of this in the UK and in Europe and in America and now in Australia is they have to practice X amount of hours over 12 months to maintain that standard, because we start to forget. Once you do that and you get deployed, they get used to being experienced. And then with experience, their judgment starts to get better. And it's really important, because you can't get good judgment and good teamwork if you don't have training, practice, experience. So, you know, those 3 areas, training, practice, experience, are the foundation keys of getting good responders up to a standard when their judgment and their teamwork matters, and they don't have to second guess, they know. And just to give you an example of what's going to be coming in a few weeks' time, is those training standards are the same everywhere around the world. The terminology is the same. So the idea being, in the UK or in America, I can have East, West Coast, I can have North Coast, South Coast, I can have teams from the military, I can have teams from fire, I can have teams from the police or the Coast Guard, or voluntary teams. They are trained in the same way, the same PPE, and they understand terminology. And as a national manager, that means I have a resource. And because I can put teams together and create task forces, that means I know that they're going to be operating safe in a safe bubble. Thanks, Helen. So that concludes our part 3. Are there any questions? And let Shayne come back on as well, just in case.
Thank you so much for the presentation. Indeed, it was very informative, and very important to note that these PPE, in fact, are designed to also to be part and parcel of rescuing the rescuers, because of, I'm sure indeed there are a number of incidents where the first responders, they become in trouble and they need to be protected. And thank you for highlighting that very well. And I would like to take some questions now. Those who have questions, you can raise your hand, or you, if you don't feel like talking, you can type them in the box. Thank you so much. Any questions?
Yeah, your personal protective equipment statements is very critical, because even our most recent floods here on the eastern seaboard and inland, we had a number of surf lifesavers who volunteered and used their inflatable rescue boats and had wetsuits. So, and as Adrian reiterated again when he talked about the safety aspect, that we put a lot of work into making sure that anyone that's involved in life-saving and rescue has all the right equipment and the right training. But we seem to think that we don't need to apply that when it's an inland waterway, because we don't have massive waves or anything, and people underestimate the dangers that's in that actual water. So it's a great point. Someone's got a hand up, so I'll be quiet for a minute.
Thank you, Shayne. We have a hand from Dewart Venter. Please go ahead.
Thank you very much. The previous presenter had a slide there with the person floating. I don't know if you can get it up quickly again. And then it says face down. And that is one of the confusions. It should read feed downstream. Otherwise, it can be confusing, and it can lead to wrong training. Just a thought.
Just have a look at that slide. Just go back. It might be a glitch. Just go back to Helen. Just go back. There's a cartoon picture on that. Let's just double check on that. Yeah. So if you are in the water and you should lie back, face up, feet facing downstream. That's the correct way, as the picture shows. And then you should be looking downstream at your feet to make sure that you can see any hydrology that's going on and debris that you can kick off. So I'll check on that slide. Or Shayne, can you check on that slide for me?
I think it just needs clarification where you're actually looking downstream.
Yeah.
Yeah.
Okay. In the meantime, can we take other questions that are there, even if it's a comment?
Yeah. Mizzy, I've got a question that's come out just to share. Is about the helmets. So where we go, wait, face downstream. Yeah, looking downstream. So I can see his point. Yeah, feet up, looking downstream. Hopefully the picture says that. Just move on to helmets. So in European, the EN 1385 helmet, or the GAF, or the white water helmet, is for low velocity or low energy water. In the UK, we're now using PAS 028, which is for speeds over 16 kilometers, because if they land into water, water at speed has, you know, a mass that is half that of say a ton of rock, and so they can do significant damage. However, we're starting to see some of the 1385 helmets getting very close to the PAS 028 standard. So here in the UK, they're asking for powerboat operators and crew to start now moving into PAS 028, which only happened in the last 12 months. The main thing for me is I think there's still work to be done nationally and internationally on that, because if you look at the standards, 1385 has continually been upgraded over the last 15, 20 years, where PAS 028 hasn't had an upgrade since 2002. So so I think some work in that, but I can understand why powerboat operators would want to be using a powerboat helmet, and I hope that's answered that question.
Thank you. Keith Matthews, I see your hand is up. Go ahead. You are muted, Keith.
Okay, hi. Good day, Mumsi. Thanks. The previous speaker mentioned where life was lost with a rescuer as he was pulled under while performing the rescue in a river. Me from a surf licensing background, we got a mechanism, and I'm sure the speaker also is aware of that, where we do the belt swim, where we can release the belt in order to prevent the rescue from being pulled under. Has this mechanism been maybe upgraded or improved to prevent a similar thing from happening, doing a boat, the river rescues?
So Keith, to answer your question, and thank you, I think I've heard you correctly. So just to make sure I have, so you're saying that they're on a tethered line connected as a rescuer and the rescuer goes out to the victim. And so in order they don't get pulled under, they can self-release. Is that correct?
Yeah, that's correct, yes.
Yeah, so in flood rescue world, we do talk about that, and it's a very highly trained area. So the first thing we do is teaching about the PPE and the requirements for the flood rescue PPE, and in that there is a self-release system. There is also understanding of first of all, it's a type B canyon line, which is a floating line. So it's a Kerr mantle core that floats, but it has a strength of 1.8 newtons. So it has a lot of strength, and the idea that line floats. And that rescuer is trained to self-release if they get into trouble, and they are trained to self-rescue. And so, when we teach that in terms of what they need to do, it's actually, once we see them do their swim test, it's the next test we do is to make sure they understand about how to release in a situation. So we actually, with the flood people, we put them into a bit of a nasty bit of water, we make them swim into it, we hold the line, and then they have to release themselves. And yes, and then part of that backup is that they have a water knife specially next to them, which if they are in further trouble, they can cut that line and be completely down to their self-training. But prior to all that is the hydrology learning and the pre-plan rescue before we do it, So yes, so all that's covered into it.
Okay, brilliant.
I just want to add another point as well, Keith, just another point to finish off. We've seen a lot of problems with different types of carabiners. We've seen the wire gate, which we've come away from because that's caused problems and been pulled through under forces. As you know, with a carabiner, they have to be top and bottom loaded, not cross-loaded. And we've also seen problems with the old screw gate, so where humans get lazy. So we're now advocating the tri-lock carabiners. So once it's locked, and then when they use the tri-lock, it's easy to get out, and there's no ambiguity about when half loading a carabiner up. So we've moved into that world after doing a number of tests with that.
Okay, brilliant. I can see you guys have got multiple choices to self-preservation. I love that. No, that's good. Unfortunately, you used to lose a life, in order to improve it. But thanks, that's awesome. Your chat stuff was great. Thanks.
My pleasure.
Thank you so much. Is there any question, Helen, on the chat?
There's a couple of questions that have come through. A couple of comments. Thank you very much. It's a beautiful presentation, a very clear message, very educative. Does Lifesaving South Africa offer inland swiftwater rescue training? We have in the past, and we're looking to do so in the future, but not at this present moment. This is why we're reintroducing it at the moment. APA provides swiftwater training, which is correct. A question from Alan Kiza to everyone. How possible is it to have a diploma or certificate training in flood risk management?
So Helen, we can do that. We'll talk about training levels next week, not to take too much next week because we want people to come on, but Shayne and I will talk about the training. There are 5 training levels, one being water awareness, and it goes all the way up to management as well. So if they want, not to take away next week, but if they want to come on for our part 4, we will talk about the training, the hours, and what's entailed in those to really showcase, and that will funnel in finally, everybody's got an understanding of from the strategic level, funneling right down to the practical points and how they can go about that. And and I know we're working closely with you to look at that for the future.
Okay, thanks, Adrian. The issue of PPE in Africa is tough to find. This is from Karani Pools. Kindly advise how much we are allowed to improvise.
So my recommendation is not to improvise, because unless you've got it tested properly, it kills. And I don't sound not too blunt about this. We have killed firefighters in the UK, we've killed firefighters in Europe, and we've killed firefighters in America. We've got it wrong. And so having the right kit means the responders are safe and protected, and they can stay in the fight for longer. So if you've got problems with that, I know of a manufacturer who's helped us, helped Europe, helped Australia, and they can support South Africa very, very well. So, and they are international with their ability. So we can answer that question. And just to give a bit of more support, they've been part of our research as well. So they've allowed donations of lots of suits to be destroyed, so we understand what's going on with somebody who's rescuing somebody. So we can help you in those arenas.
Thank you. Comment from Alistair to Keith that one must also consider the environmental conditions in the release mechanisms. In low temperatures, you will lose functions of your hands very rapidly.
Yeah, that's true as well, Helen. So we know from the research, we've got some papers on that. So what we found out that depending on the speed of water, you'll cool between 4 and 25 times quicker that of air. So, and when we did the thermodynamic paper, which if people wanted to see that, I'm happy to send that out. We looked, and as Shayne said, we saw between 4% to 20+%. Shayne can correct me now because I'm guessing a little bit, but we saw pretty much in the first hour on a cold day that your main muscles as a responder start to be affected, whether it's grip, dexterity, or jumping up and down. And that's really important for us to know, because if you're doing this for say 4 or 5 days in a row, the ability to respond to think about rescue and to enact a rescue starts to be compromised, which means for managers, we do need to look after them.
Yeah, okay. Question from Job. Could it be possible to package a standard international course on flood rescue training, just as there is for pool lifeguard or surf lifeguard training?
Job, good to hear from you again. Stay tuned in 3 weeks' time for our final bit, and we will share all the goodness with you.
Okay, fantastic. Thank you very much. I'll hand back to Mzi. There's nothing further here on the chat line.
Oh, thank you so much. And I see there's also no other hands that are up to the presenters. Shayne and Adrian, thank you so much for such an informative presentation. It is indeed very much helpful. And we are also looking forward to the part 4, which will be talking about the training standards, as well as some of the interventions that needs to take place as far as the training is concerned. I see that our next presenter is in the house. Ireen Mutombwa, can you please share your presentation? Or Helen, will you be sharing the presentation? Irene is here and she can now start her presentation. And thank you so much. Irene, over to you.
Irene can share her own presentation if she has. Irene, you will have to unmute yourself. I think she's just got lost at the moment. Just give her a moment to reconnect.
No problem.
So the final, I was trying to say that the final presentation will be taking place Wednesday. Z.
Hello, Irene, are you still there?
When will the final presentation be taking place?
The final presentation will take place in the next 3 weeks as well. And then we will communicate effectively to all the participants. And we urge everyone to attend, because we feel that that is one of the very much important presentation. I think it's taking place on the 27th.
The 27th of May.
Yes, 27th of May.
Okay, all right, just that everybody can diarize that at this point in time. Here's Irene again. Let's just wait for her to join in again. We apologize. She's had to deal with a couple of disaster management meetings this morning related to the current disaster that we have in the Cape. It's from the storms that have hit the Cape over the last few days. So Irene, welcome. You will need to unmute yourself and share your screen.
Hello, Helen. Yeah, I'm having network challenges, so I just dropped you my presentation so that you can share from that side.
Okay, Irene, if you can just start from your side, I will catch up with the presentations. If you don't mind introducing yourself.
Thank you so much, colleagues. I'm Ireen Mutombwa. I'm the acting National Disaster Manager for the South African Red Cross Society based in Pretoria, but working in all the 9 provinces of South Africa. Have you received the presentation?
I haven't received the presentation at this point in time. Would you share from your side?
Currently, actually, what I did, I'm
Sorry, Irene. I think speak through your presentation in the meantime. We'll try and get it up. Apologies to everybody for this. It will take us a little bit of time. We do understand that this may impact on our end time.
because it will be easy if at least you can project from that end, because it's on my laptop is something else. You got it?
Unfortunately not. I don't know how large it is, so it's obviously taking its time to come through.
Oh.
Maybe Irene, you can just click on the Zoom platform. There's a button where you click share a screen. Unless Helen, you got it already.
Yeah, I'm trying. When I joined, I had tried to, but only the network dropped. So that's why I opted to join through, to just join with my phone so that at least I'm still connected to the meeting.
Oh, maybe you can go through your presentation, even if it doesn't project. Maybe you can project it in your computer and then you go through it while Helen is actually waiting for the presentation.
Mm.
Check your spam box, Helen.
No, nothing in my spam box, nothing in my inbox.
Could be something to do with the size of the presentation.
I'm in.
That's correct. Okay. All right. Fantastic. That's great. Share from your side now, Irene.
Have you given me the right to share?
Let me just find you again. Everybody's got, you have the right to share, so you shouldn't have a problem.
not having the option to share from this end.
Okay, try again.
Yeah, the mishap.
Thank you. We can see your screen.
Okay, perfect. So the South African Red Cross Society, it was established by the Board of Parliament of South Africa as a voluntary and development organization to the public authority.
Irene, I think we've lost you again. I see your connectivity is definitely an issue, and I apologize, I've not received your presentation. I think from a time perspective, Irene, if we'll have a chat offline. Thank you very much for joining us. I'm just going to give Daya Sudith, our president, a moment just to highlight a couple of aspects that have taken place in the last couple of weeks, which have very positive aspects to our movement in drowning prevention. So I'm just going to share my screen for now. Irene, when you get your computer back up, we'll see. So,
all right.
Okay. Daya.
Helen, Irene is, okay, she's muted, thank you. May I suggest, firstly, greetings to all our participants and our presenters. As Helen has introduced me, if you are joining us for the first time, I'm Daya Sudith, voluntary president of Lifesaving South Africa. I may suggest that we could actually incorporate Irene in the next leg. Maybe we'll have to negotiate an extension of the time, or we could accommodate Irene if there's further connection issues in the next, in a dedicated session. So I wanted to greet all the participants. It is exciting to see that we have retained such a large participation. I think there's, again, almost 70. And what's very, very encouraging is that we have such a huge participation from all over the world. So it's exciting to see we have international participation. And certainly this must be a testimony to our international experts, Shayne and Eddie. Thank you very much for your presentations that you have taken us through. And you're certainly pointing out to the fact that we really need to actually have more of these sessions or package them in particular ways around, around qualifications, around training with the environment. Eddie's point is so important. The climate change issue is not gonna go away, and we really need to actually make sure that we be cognizant of this. I just wanted to note that that when we had the second webinar, I shared a slide with you, which was very parochial. It was very South African based. I'm not really going to apologize for that, but it was used to actually show how in our country, it illustrates a lack of readiness and a lack of preparedness, particularly at local government level. But seeing that we have an international audience, I wanted to suggest that looking at the slide that you see that Helen has projected, I think you're all aware that we've had one of the most significant developments in the whole area of drowning prevention. On the 28th of April, the United Nations adopted the resolution on drowning prevention. So this has been one of the most significant, as I said, developments politically, and I think we're all still dealing with the implications of this. From International Lifesaving Federation, the initiative started 10 years ago at the World Conference of Drowning Prevention in 2011. And there is a seminar that's coming up next week, which we will share details with you. And it was really given a boost at the World Conference of Drowning Prevention in 2019 that Lifesaving South Africa hosted in Durban. The advocacy really ramped up in October 2019 in Durban. You see Gemma May there from the RNLI, who is a champion of this particular initiative in New York at the United Nations office. And I think we are all absolutely thrilled to hear that the United Nations Declaration on Drowning had been adopted and supported by well over 80 countries. Bangladesh and Ireland led the whole struggle at the UN, and this is really a huge development. In our very first webinars, we focused on these issues, and that is why we have had the flooding disaster that actually came out of the World Conference on Drowning Prevention in 2019, where Shayne and Adrian had actually run a full-day workshop. We've chunked it into four parts of an hour each. But the question is, what does this all mean? How do we go about unpacking it? And obviously, I'm not going to spend time doing that now, but it's certainly going to point to us having similar webinars to actually unpack and look at the implications of the UN Declaration of Drowning. But I will end off by saying that on the 25th of July, the United Nations have declared that it will celebrate the International Day for Drowning Prevention. So hopefully seminars like this, and we'll certainly drive the agenda in South Africa, will try and bring in government and non-government organizations and all other organizations like the ones in this forum to work towards celebrating or honoring or acknowledging the work that has gone on and what still needs to happen on the 25th of July. So we will certainly keep you informed. Helen, thank you for a little bit extra time. Maybe we'll just negotiate how we manage Irene's presentation going forward. But I would like this audience to know that we will certainly rally all of our organizations together to give expression to the UN Declaration on Drowning. And I thank you for this opportunity. And I thank all participants for participating, and thank you for your patience. We really appreciate the fact that you have stayed the course, which actually means that the information has been useful and we can only grow from here. And thank you once again. Bye-bye.
Bye, everyone. Thank you. See you on the 27th of May.
Thanks very much.
Session. Thanks, everybody.
Thank you, everybody. And Irene, thank you very much for making your time available to us. We apologize for the IT glitches and the connectivity issues, and we definitely will include you on the 27th of May. Thank you very much. Have a good day, evening. Thank you as you go on your way.
Thank you. Bye.
Bye. Thanks, guys. Awesome.
Bye-bye.